Hello guys, welcome to another episode of Xahlee Talk Show. We are going to code Wolfram language today. I'm gonna show you how to do animations in Wolfram language. Look at these beautiful, fantastic animations. So let's start Wolfram language. Okay, so I already got it started. Let's start afresh. Okay, let's start a new session. So animation, so there is one, then new notebook. And if you don't know already, just go to my website. I have a complete tutorial on Wolfram language and where to download. Okay, start Wolfram language notebook. Now the kernel is launched. Now let's show you some more animations. So you can see that another one, snowflake, beautiful. Stop. Let's show some others. So this one is done 30 years ago. Those are 30 years ago. And here's another one, flashing diamond animation. Now when you generate an animation in Wolfram language, you can export it. And you can export it in GIF, in MP4 movie format, and in variety of formats. Okay, so here's another one, play. And you can also generate a sequence of images in SVG format. Then you use JavaScript to create a player like right now. So the advantage of this is that you can go frame by frame like I'm doing. I'm scrolling the mouse wheel up, so sometimes you want to see the beautiful details of it. Okay, so for example, let's say this one. This one, copy the code. If you are watching offline, play at 1.5 speed. Okay, so let's there it is, a code. Let's magnify and Control Shift N to make it typeset. You see, typeset is beautiful. They are dynamic, with dynamic formatting. You see, they cut the lines at appropriate places. You never have to press indent, or tab or space. Okay, so now evaluate the code. Oh, okay, so yeah, so it's done. So you can see, let's stop that. Okay, so go here, stop. So there it is, the animation. You can play it forward only, or you can play it backward, or you can loop forward and backward. Okay, and you can adjust the speed. Press that to adjust the speed, and let's loop backward and forward. Okay, stop. Or you can drag the slider. So this is fantastic Wolfram language animation. Okay, let me show you from scratch how to do that. You see, I have right now, we are doing this animation, fancy animation of a curve of a trachoid, which is a plane curve, which is also known as spiral graph. We talked about in a few days ago. So go watch that. So this is a fancy animation involving the curve, the blue one you see, and also the normal lines, that's the red lines. Okay, but we're gonna show you how to do animation from scratch, like moving a rectangle, things like that, or rotating a rectangle. Very simple. Okay, so first of all, you go to xahlee.info, Wolfram language tutorial, search for it, you'll find it, and you can download it. And Wolfram language in depth, this complete tutorial from scratch. If you already know a programming language such as Python or JavaScript, you'll be have fun. Okay, so and this is actually in depth. It it teaches you how to program, how to understand Wolfram language, because Wolfram language is different from all the other languages such as C, C++, Java, C Sharp, JavaScript, Python, Ruby, Perl, PHP, Bash, or Haskell, or even Lisp. So it's very different from all of them. Wolfram language is a symbolic term rewriting system. So basically what it means is just every syntax, it just keeps replacing the syntax to get the result. Okay, kind of like Lisp macros. Okay, so download it. Okay, download it free. Read about the details about Wolfram language, Mathematica, Wolfram engine, Wolfram script, what's the differences, and okay, and there's a full tutorial. Okay, so let's begin. So Wolfram language in depth. So today's today's talk show. Let's put the link here. Showing browser. Okay, let's do an animation. So animation, the easy, it's very easy. So all you have to do is just say, let's save it. Okay, untitled one, X untitled one. Okay, now let's see. So animation, what do I want to show? Sine wave. Okay, let's plot sine. Okay, so I'm also using Wolfram mod in Emacs that allows you to code Wolfram language in Emacs. So the key is that, and here's the documentation. So you got all these commands. So let's jump to the source code. Here's the source code, 3,000 lines, but most of it is the Wolfram language function names, because Wolfram language has 7,000 functions built in. By default, out of the box, you do not even have to load a single library. So 7,000 functions. So okay, so go to the top and go to here, open that URL. Here is a homepage for Wolfram mod. It's free on GitHub. Okay, download and use it together with Wolfram engine. So let's paste that there. Okay. So now we're gonna show animation, show sine. Okay, so first of all, let's start a Wolfram language code in Emacs. Okay, pop it out. So we want to plot sine. Okay, plot sine. Let's say x. Okay, so x goes from 0 to 2 pi. Okay, now go to the notebook, show it. Fantastic. Next we're gonna animate this. So let me show you a different plot. So when you study pre-calculus or or calculus, you can have like a variable. Like what is the effect if you put a variable inside the argument to sine? So 3 looks like that. What if you have 4? So you can do, so okay, so let's type it here, table. Okay, table, I want the table of sine, 2 arguments. The first one is expression, which is plotting sine. The second one is a list. Let's say I want t here, t goes from, let's say 0 to 1. Let's not say 0, because sine 0x, that would be, so it's gonna be 0, sine 0. Sine 0 is 0, so it's gonna be flat, just a line. So we don't want to start at 0. Let's say, okay, so let's do that. 0 to 1 in increment of 0.1. Okay, copy that. Select, paste, run it. It's gonna generate a sequence of graphics. So you see, but now you can notice the plot range changes. Oh no, it doesn't. So that's a difference. Okay, So table generates a list of things. In this case, a list of graphics, because this plot returns a graphics like that. Okay, table generates a list of graphics. Now you want to animate it, so we can do that. Let's say let's put some commentary. Plot sine curve. Okay, and this one, okay, then this one is generate a list of sine curve. Okay, that's table. Then then we want to animate it. Okay, show animation of a list of graphics object. Okay, that's how you do it. And here you want to just say list animate. Very simple. Okay, so let's copy that. So list animate is a function, and what that function does, wait, so you're missing something. Okay, list animate is a function, and it takes an argument of a list of graphics, which is that. Okay, so let's copy that, paste it there, run it. There it is. So you can see this list of animation. Now you notice it jumps a little bit. You see, we don't want that. We want the frame to be fixed. So how do we solve that? We specify in this plot, we specify plot range. Yeah, so it's fixed range. Otherwise, it's automatic, determined by what is the content of the plot. So you want fixed plot range, which is kind of the frame. Okay, so plot range takes an arrow like that and takes a list. The list contains two things. The first part is x from, let's say, from 0 to 7. Okay, and y goes from, let's say, -1 to 1. That shows the range. So we can try it here. Do it. So now you see it doesn't jump around. And you can play it back and forth. Let's back and forth and speed it up. So this kind of show the effect of changing the t inside the sine parameter. Okay, so this animation feature is greatly very powerful, because then you can do x squared, x third power plus 4x squared, let's say minus 4x squared. So you have complicated polynomial. You can plot it, and you can also have a variable. Let's say this is t, and you can change the any of the constant or variable, so you can see how it changes the graph. So we can let's just, for the sake of completion, let's plot that. Okay, so back here, so this is the expression, copy it. So we want to plot. Okay, so this time, so it's this expression, plot that, not sine. X goes from, this time, let's say x goes from -5 to 5. Okay, and we can do that. Oh, then we forgot to change the plot range. The plot range, let's say -5 to 5. Then y goes from -5, let's say -5 to 5. Okay, shift enter to evaluate. Okay, so it changes slowly. Now if you say t squared, it's gonna change. Let's say 2t. Okay, so this is fantastic, and it also show it can do it in 3D. So let me summarize what's going on. Okay, summarize how to generate animation. So all you have to do is you can plot something. This creates a graphics, but it could be anything. You could return a number or whatever. Then you use table to generate a list of them. So you got a list of numbers or list of graphics. Then if it's a graphics, then you just put it inside list animate. Okay, so for example, let's name it so it's better. List x graphics list equals to. Okay, so we can do that. Then all you have to do here is just say that, and we want the plot range. Okay, so plot and plot range that. Okay, so and here we don't need that, so that. Okay, then delete that. Well, that's polynomial. So like that. Okay, so now select all. Let's put a Alt 4. Press Alt 4 to create a subsection. Okay, fantastic. Actually, delete the whole subsection. Alt 4 subsection something. Paste it. Okay, here's our code. Press Shift Enter to evaluate it. So first of all, we got a list of the graphics, then we got the animation. Now usually, this list of graphics, sometimes there's hundreds of them. You don't want to see it, so you put a semicolon at the end to suppress that output. Okay, so then you got this. Beautiful. Comments. If you are here, say hi, say comments. Okay, so now we created an animation by creating a list of graphics. Then we just use list animate. Okay, now another way is to just create graphics directly. So let me show you. So this would be interactive graphics. So how do we do it? So instead of table, so you see here you use a table and two arguments. The first one is expression. But now let's say, you say instead of table, you call manipulate. Okay, manipulate basically takes the same kind of argument as table. So manipulate, takes two arguments. One is the expression, the other one is the variable and what you want it to change, a range. Now manipulate is just like table, but instead of creating a list of things, it just create a interactive graphics where each frame is one of the variable value. So we can do that. So let's say manipulate. So let's do it here. Press show it. Okay, so you see now you don't have animation, but you do, but you open that. So now it shows the value, so you can drag the slider to see how it changes. Okay, now let's make it more fun. So instead of t goes from, let's multiply it 2. Okay, so this way it's actually more fun graphics. Now so Oh yeah, so let's change t, the value of t. We want to go from 0, starting from 0 to 2. Okay, now shift enter. Now it looks kind of, that means more fun graphics. So you can see, let's drag the slider. Fantastic. So this is, sign, which is a fundamental, actually it's the most important function in mathematics, almost essentially, like effectively the most important, or top 3 most important function. So when you have sine, you have wave. So radio frequency, whatever, it's all waves, physics and stuff. Hey Diego, good morning, sir. So fantastic. Now you can also play as animation. And let's say loop back and forth. Okay, and let's increase the speed. Fantastic. So when you have an argument inside sine, it changes the frequency. You can also change the amplitude by changing the thing before. Or you can make it more complex. Let's say sine x over x. Let's try something like that, okay? Sine x. Okay, now it's gonna be more complex. I think it's gonna be sine of sine. So ooh. Okay, shift enter. Let's see what it looks. Oh, interesting. Let's see. Play. Back and forth. Fantastic. Okay, so that's manipulate. Again, manipulate just take 2 things. One is the expression. In this case, it's a plot, which generates a graphics. The other part is the variable and range to change. Okay. I got a call, so hold on a second. I'll be right back. Hello, I'm back. Check, I'm back. Okay, fantastic. Is it fantastic? Let's see. So we got the animation. So let's copy. So manipulate. Okay, manipulate, super useful. So let's put it here. Here's a more complicated example. Fantastic. Okay, so we showed 2 ways to generate animation. One is just stop that. One is just create a list of graphics, then just say list animate. The other way is just directly use manipulate. So, okay, so both way works. So now, what about exporting to MP4? Okay, so for example, this one, you can just export, copy that. So you just say, let's set it to x equals to, okay, shift enter, do it. Okay, so now you got a value. Now you just say, let's type it here, x equals to that. Then export takes 2 arguments. The second argument is whatever you want to export, which is xx here. The first argument is the file name. Okay, so let's say sign of sign dot mp4. Okay, copy that, paste it, run it. Okay, 20 seconds, 10 seconds. Okay, done. Now go to document folder. Let's see, where is it? Sign of sign there. Show in the Explorer. There it is. Close that. So you can just open it. So let's open it. Sign of sign. Yeah. Okay, so wait. So copy that. Close it. Put this back. Syntax color showing browser. So that's what we have done so far. Now move down. Paste the file path of the MP4 movie we just generated. Linkify it and move it to the current directory there. Okay, sign of sign. Now showing browser. Move down. There it is. So you click on that. That's our animation. Fantastic. So if you want to loop, you have to say loop. Okay, let's say refresh, play. Fantastic. Okay, so now we got the MP4 animation, but you can also do it as GIF animation. So GIF, do it. Okay, it's done. Go to Documents folder. Refresh the browser. There is the file. Open it. That's a GIF file. Open in the GIF in the image viewer. Fantastic. Fantastic. Control H to show original size. Fantastic. Okay, cancel it, copy the file path, close, close. Now let's put the GIF animation here, link it, and change the file location to the current directory. Okay, showing browser. Go down, that's MP4, and here is GIF, automatic. Now you see, if you don't want the sliders to show, you see these sliders are just part of the movie. They are not active. So that's what you get when you, let's stop it, okay. GIF you cannot stop, but you can actually GIF, right click. Oh, you cannot stop GIF or something, I forgot. Anyway, that's a browser web dev issue. So anyway, you got a GIF. Let's see how large is the file. Okay, so show, so 700 kilobytes, and the MP4 is much smaller, 99 kilobytes. You know, it depends on the animation. Sometimes one is larger than the other. Okay, so but typically MP4 is much more efficient. But MP4, you know, is not always the best, because when you have GIF, the pictures are crispy. But MP4s, you know, may not be, because when you have line graphics, okay. So anyway, so you got GIF animation, you got MP4 animation. That's how you export. Now, but you don't want this bar. So in that case, if you don't want this, you know, inactive bar, you just use the generate a list of animate. So you know, here we have a list of graphics. So you just say, let's go back to Wolfram language. Let's go back to code it here. Okay, so show animation and export that. Okay, so export. So export just the graphics list. Okay, so that's what you want to do. Okay, so copy that, paste it, do it. Oh, you forgot to suppress the images. Okay, but anyway, there it is. And now go to documents, search for sign. There it is. Copy the file path, close, go back to talk show, paste link, showing browser. Wait. Oh, here. You see, now you don't have the inactive slider at the top. Okay, I think that's it. Why don't we show something like fancy, interesting, or you know, wait, what is going on? What? File exists. What am I doing? Oh, there's already that file, so you gotta rename it. Then move to the current directory. Okay. So, and the Wolfram code, now let's clean it up. So you got export. Okay, export, yeah, that's good. So you can also export to GIF. Let's just show it. Okay, put it back, syntax correct, showing browser. Okay, I think that's it. We oh yeah, okay, so now let me show you how to program graphics, because so far we used a built-in plot function to create graphics. But what if you want to draw your own graphics? Let's say you want a circle moving here and another circle moving here and they collide or whatever. Okay, so how do you do that? Very easy. Okay, let's start the code again. So let's copy this, put it back, color it, go to the bottom, and let's start a new section here, paste the code, undo, Wolfram language code block, paste it. Okay, so now, so what is so this is create your own graphics for animation. Okay, so let's code it. So let's say move a circle. Okay, so you gonna do, so graphics circle is represented by a circle. Okay, circle takes a center, let's say 0, 0, and radius t. Radius is, let's say, 1. Okay, now to show this as a graphics, you just call graphics function and put the circle inside. Okay, and you want, say, axis true. Okay, copy that, back to Wolfram, stop all the animations, because otherwise it's cycles the CPU. So run it. So you got a circle. Now you want to move it, just like before you use a table. Okay, so but instead now the table, the expression is gonna be that. Okay, so we want the expression to be a graphics of a circle, and the circle, let's say we want to move it from the center to 0, 1. Okay, so So that will be a variable t. So t will go from 0 to 1 in increment of 0.1. Okay, that will create a list. And then you also want to say plot range. Okay, I'm not sure this works here, but let's copy the plot range. Okay, so something like that. Okay, that will give you a list of graphics. Let's just try it. Fantastic. Oh no, so you got something wrong. What is wrong? So circle t radius 1 so t goes from 0 to 1 in increment of 0.1. So let's look up circle documentation. Circle XYR, okay, center and radius. Okay, then you also can do generate a eLisp. Okay, that's not okay. Okay, but why are we getting an arc? Oh, right, we are moving up. So with the position of our parameter is incorrect. So we want to T0, okay? Shift enter. Fantastic, now it kind of moves. So let's say T moves from 0 to, let's say T move from 0 to 10 in increment of 1. Shift enter. Fantastic. See? So now, so this is good. Copy it. Copy. Move a circle. Okay, so now we just list animate just like before. Okay, copy it, and we can in fact do the whole thing. Moving circle. MP4. Okay, copy all. To go here. Go here. Paste. What? Copy all. Paste. Shift enter. Fantastic. Let's see. Fantastic. Okay, that's how you basically create your own graphics. This is, and then animate it. Okay, so I think that's it. So if you want to know more about creating graphics, such as you know, these kind of fancy things we have, or yeah, let's show some. Yeah, let's do a fancy one. Okay, then we close. So put this back. So if you want to know about how to create complicated graphics, we have a tutorial before. You just go to xahlee Wolfram language, xahlee Wolfram language in depth. Then there is a section. Okay, go to the Wolfram language, copy. Hold on a second. Wolfram language tutorial. Yeah. So actually I want that link. Wolfram language tutorial, you go to the video tutorial. So I've done like over 100 videos. So there's one about how to program graphics. So you can program. So let's do a fancy one. Okay, you can create complicated ones like that. This is actually my favorite. Okay, and we did this live stream. You can find it. Live stream, what date is it? 2021 August. So go to YouTube, you will find it. Okay, so paste it, run it. Fantastic and beautiful. So you can see, you can rotate it. But now let's do something. Let's animate it. Okay, so yeah, let's try to do this fancy one. This is called geometric inversion. Okay. Now if we change your parameter, it's going to be, yeah, we can, let's just see. Okay, so show in browser, yeah, create a new section here. If you like my tutorial and videos, go tell your friend, post on your Twitter, your blog, okay, and donate to me. Okay, so go to xahlee.info and scroll down. So you got 6,000 pages of programming information, technical Unicode, character frequency, programming languages, keyboards. You got logo design. You got, well, mostly programming language tutorial. Okay, so you got all these languages. And you got mathematics. Okay, lots of mathematics. So you can pay me. You can get the entire site in a zip file. Just pay me $300 via PayPal. Use my email address there. Okay, or just donate to me, Amazon gift card and PayPal, or Patreon me. Okay, thank you for that. So, but now we want to show. So what we want to show, we want to do this animation. Okay, yeah, let's do this animation. So oh yeah, so but so when is this? 2021 August. Talk show. Okay, go to the directory, show that date. There it is. So there is a talk show. There is the talk show. There, show in browser. Yeah. So we did this live 2021 August 1st. Beautiful. Okay, but yeah, so let's do the animation. Okay, so actually copy that, close that. Go to today's talk show and paste the link, a reference to the previous video. Now let's do the code. Okay, so what this code do, let's copy it there. So you got formatted code, kind of. Okay, so you want to manipulate. So just like before, we call manipulate two arguments. The first argument is an expression, which is that. Okay, so the second argument is a variable that changes parameter. But what we want to, okay, that's easy. Let's change this one, 0.8. Okay, so make it TT. But before we do that, make a copy. Okay, cut, copy, paste. Okay, now change this 0.8 to TT, and manipulate. TT goes from 0.8 to let's say from 0.1 to 0.8. Okay, and I think that's it. Okay, so but this will involve okay, I think it'll work. Okay, but the code is kind of ugly, and we also need to fix the, you see kinds of the frame moves, so we need to fix the frame. But anyway, let's try this. Okay, you got a problem. Oh yeah, you forgot to copy that. Paste. Okay, Shift Enter. Fantastic. That's what I was expecting. Okay, now show the widgets, loop back and forth, play. Yep, that's what I want. It increases cube size. Yeah, beautiful. So if we, fantastic. Okay, I think that's it for today. Yeah, thank you guys for watching. So goodbye, and so we shut down in a minute. If you have questions for me, ask it now. Okay, and we, yeah, so I'm going to wait. Did Wolfram language just crash? Oh shit. Or did I just close it? Let's open that. Yeah, I didn't save. Okay, so let's just run it again. Oh wait, it's here. Okay, so select all, paste, Shift Enter. Okay, run it and save it. You know, it would be beautiful. There's another thing to try. Okay, so first of all, click on that, Shift Control N to typeset it, and now I'll make it whole thing smaller, 100%, and let's see, Shift N to run it again. I want to do add a screenshot of these. Okay, stop. So we can copy these. Okay, so now, yeah, I think I'm gonna stop. How long have you been working with Wolfram language? Hey, Francie, are you the Francie I know? I've been working since 1992, 1993. I've been coding Wolfram language, especially in the 1990s. I coded every day. So, okay. Thank you guys. Bye. Yeah, that's it. Stop. Yeah, okay, shut down. Yeah, we are done. So delete that, put it back, syntax correct. So there is today's talk show. Oh, middle of night. So yeah, I should change. You know, usually, you know, I haven't. So in the past year, usually I do local time at noon, San Francisco time noon. Usually, so that means it's like you know, I guess middle of night for you guys. Yeah, but so if I do it in 6 p.m. here, San Francisco time, then that would be like 3 o'clock in the afternoon for you guys, I guess. So is there RSS feed for your site? Yes, of course. If you go to xahlee.info, you can see I have like 7 blogs there. There's keyboard blog, there's RSS, you can subscribe. RSS is kind of dead. Nobody, you know, like very few people even know about it. So Emacs blog, there's RSS feed. Programming blog, it's all about programming languages. So there's RSS feed. Then web dev blog, it's all about JavaScript and HTML, CSS. and website technologies. So there's a RSS feed, then there's also math blog. Look at this beautiful, we did a few days ago, this kind of sunflower pattern, technically called hypotrachoid, the nested evolutes of hypotrachoid. That's what this sunflower pattern looks like. That's a name for it. And you see this equation, fantastic. So math blog, there's subscribe, RSS feed, and Unicode blog, there's RSS feed. Okay, so that's my RSS feed. Bye.